Good morning. Good afternoon, everybody. We have a lot to talk about as there's a very dynamic trough that is forecast to eject tomorrow across the Great Plains. And I'm going to give you a live, detailed update on what is happening, the latest of the forecast models, what my plans are to chase it. And you can definitely see the NATO cast has that 10% tornado risk painted right over central and eastern Nebraska. The Storm Prediction Center has a 2% risk, but anytime you have these really dynamic trough ejections, a lot of times they end up going big. Just gotta plug this in really quick. Thanks everybody for joining me. Dominate that like button if you can. There are some vibes that are kind of similar to the Spalding intercept from May 12th. Definitely a potent close, upper level low, possibly east to west moving supercells on the north side of it. See if I can deploy this post really quick. There we go. Thanks everybody for joining me. A lot to talk about today, and we're going to be breaking down hodographs. And the hodographs are very favorable. Usually the hodograph is used to plot the wind fields, and instability is going to be the big concern for the setup tomorrow. And that's because we have that Gulf of Mexico moisture grabber, as we call it, that big rainmaker down in the northwest Gulf of Mexico. And that could potentially lead to kind of a meager moisture situation into the Great Plains. And I'm going to be going over that, but I definitely am going to show you what favorable kinematics look like streaming into southern Nebraska. There is going to be a pretty narrow window for significant tornado potential. It's a pretty narrow instability axis, and it definitely gets pinched off as we get a bit later in the process. Let me make sure I'm still live here. Thank you, Team Dominator members. Never stop chasing. Looks like I went live to everybody on this one, so thank you, Team Dominator members, anyway. But there's that potent trough ejection that you see moving into central Nebraska. I think we're going to see a lot of these this season as we're still in an El Nino mode. We probably will be for the next year or two. And you'll see a lot of these strong, potent closed lows that will eject from the Rockies. You'll get Lee cyclogenesis that happens just to the east of the Colorado Rockies. And then that low pressure lifts up toward the Great Lakes. And as we get later on in the season toward winter, these upper level storm systems will have a lot of cold air to work with on the backside. And we could even see some big snow makers. This one looks like it's going to produce quite a bit of snow over southeast Wyoming and into northern Colorado. But it's really the ski jump jet exit that we really want to watch. That's where all the action happens. This is definitely the year of the surface low play, and it usually is a pretty sure bet when you play the surface low because they have a lot of strong low level wind shear. A lot of times they're at the nose of the moisture as well. Usually you'll have a triple point, kind of a dry line, cold front, warm front intersection in this case. And you also have some general spin in the atmosphere and underneath these vertically stacked low pressure systems. Vertically stacked means that the low pressure or the spin is co-located from the high levels of the atmosphere all the way down to the surface. And I'm going to show you what that looks like as well. A lot of times you get a vertically stacked storm system like this from the low levels all the way to the upper levels. A lot of people will call it more of a cold core setup, and that's because it's really driven by the cold air aloft and the existing spin with the cold air. But I think anywhere to the east of that, and if you have the moisture and instability axis that wraps up into the low, then I definitely think that it's more of a hybrid setup. But there you can see the upper levels of the atmosphere, a big bowling ball trough, and you always want to target the exit region of that mid-level jet streak. And you can see that it's nosing up into Nebraska. The image that I included as the thumb for this is from the NATO cast, and that's a machine learning product that will predict tornado probabilities. And right now, it actually is predicting a 10% tornado risk area up in central and eastern Nebraska. That's the thumb that I use for this live. And it's all driven by this low-level shear ramp up just to the east of the 850 low. We're working our way down in the atmosphere. Now we're about a kilometer or two above the ground at 850 millibars, and we use pressure to delineate the levels in the atmosphere in meteorology. You can also use height as well, but the main low-level jet axis is right down here. But you can see it ramp up just ahead of the 850 low, that ribbon of near 50 knots out of the southeast. That's really what's going to be driving this severe weather setup just ahead of that vertically stacked low. We're going to start off with a NAM model But I do think that the HRRR model has the low levels handled a lot better, with basically an arc of instability wrapping right around the north side of the low. And I wouldn't be surprised if this is similar to the Spalding, Nebraska event on May 12 this year. That was the year that we got the direct tornado intercept for the Dominator 3. And that was also a vertically stacked low that was meandering across the plains. And on the north side of that low, you had east to west moving supercells, basically driven by the steering flow of that closed low. And whenever you get east to west moving supercells like that, you better have a lot of easterly or even northeasterly low level winds to make it work. And I think just to the east of the vertically stacked low, you're going to get a lot of south to north movers at about 30 knots. And driven by those easterly 850 winds all the way down to the surface, I think you'll be able to generate enough storm relative inflow for those storms to produce a tornado threat. But it really depends on how narrow that instability axis is going to be. And the moisture situation could be a little bit anemic in the Great Plains, and that's because down in the northwest Gulf of Mexico, there's a big rainmaker down there, basically a coastal low that's going to really carve out a lot of the moisture. And as we get into the heating of the day on Thursday, you can see a lot of these dew points just evaporate through the mixing process, and that leaves behind kind of a skinny, rapidly ejecting instability axis. But definitely does have very strong kinematics. The wind shear is incredibly potent. Now we've worked our way down to the surface, and you can see the surface low ejection, at least depicted by the NAM model. One thing that I'm seeing as a positive for this setup for tornado potential is that the low pressure is going to be intensifying as it lifts up into central Nebraska. Textbook Colorado low ejection begins in northeastern Colorado and then ejects up towards central Nebraska, dropping into the upper 980s when it arrives in central Nebraska. So I do think that playing the north side of this low, where you get those easterly surface winds, some southeasterly 850 winds into your low level jet, that's probably going to be where the tornado potential happens. Maybe on the northeast to east central quadrant of the low. And it's possible even on Friday that there could be some severe weather too across Iowa as that low pressure continues to push off to the east. But just on the northeast to east central quadrant of that surface low, where you get the nice backing of the winds, that's really where I think that the greatest tornado potential is going to be. So now we're working our way down into the low levels with the 3-kilometer NAM. And it doesn't really have that arc of instability that wraps around the surface low. It does a little bit, but now I'm going back to the HRRR because I feel that the HRRR has a better handle on that arc, that skinny arc of instability that rotates around the low. So we're pivoting back over to the HRRR model for the low levels. And you can see that bright west to east band of favorable low level wind shear where it interacts with surface-based instability. And that's the narrow axis where I think there is going to be some tornado potential. They are going to be moving from south to north at about 30 knots through that skinny instability axis. And you can see that the instability doesn't really rapidly lift to the north and mature. It basically stays stable just on the east side, north side of the low. And that's why I think that you have a relatively narrow window of time for tornado potential between about 5 and 7 p.m., maybe even 4 and 7 p.m. A lot of times this year, these storms have been initiating a little bit earlier than many of the models are forecasting. And I think that this is going to be no different, this setup across central and eastern Nebraska. It's possible that they could maintain tornado potential into northeastern Nebraska as well. But that 0 to 1 EHI, that's really what we look at to see where the environment comes together, the low-level wind shear, when it's going to come together with surface-based instability. And you can see that it happens over that narrow corridor just to the east of the low. Another concern I have is just the shape of the low pressure. It doesn't seem to really ramp up the low-level jet just east of that low until right at the last second, right at about 0Z, which is 7 p.m. So the 3-kilometer NAM just has that favorable wind shear over a relatively narrow window on the northeast, north side of that vertically stacked low. And I definitely should be chasing this, but I'm feeling a little bit under the weather again. This is like my 3rd cold in a row that I've had this year. I never get sick, so kind of a frustrating situation. But this is the overlay of wind shear photographs with your surface-based instability axis. And it's even hard to really see where the wind shear coincides with the surface-based instability because of the coarse resolution here of the HRRR compared to how small that instability axis is. But it looks like right there in central northeastern Nebraska is where you want to target. And you get some of those classic kind of low shear or high shear, low instability type photographs where you get a lot of easterlies. And you need those easterlies because the storm motion is going to be largely south to north through that corridor of instability. And it does look like it lifts off to the northeast toward the Norfolk area, far northeastern Nebraska, maybe even up to Yankton. But really, it looks like when those storms are crossing that warm frontal zone to the east of the surface low, that's when they're going to be producing tornadoes. And photographs are just kind of a nice way to visualize wind shear. And Cameron Nixon has made these plots possible where you can actually see where the wind shear evolves with time. More straight line photographs down in eastern Kansas, certainly. And straight line photographs usually don't support a tornado threat. Usually they support kind of an equal dominance of the left and right movers. And you get a lot more hail production, a lot more wind potential down there across eastern Kansas. And let's see what the moisture is showing us here on the HRRR. These are surface dew points. In the morning, notice how the instability axis is pretty thick. Low 60s dew points just dominate from central Nebraska through central and eastern Kansas. But then as we go through the heating of the day, that instability axis gets a lot more narrow. So watch it just erode from the east here. You can see those dew points starting to decrease. You get a lot of dry air across Missouri. And because of the mixing process, you're bringing down that dry air from aloft in the atmosphere, and it acts to really make your instability axis a lot more skinny. But it does look like there's some moisture pooling up here along the warm front. You get the maintenance of those 60 dew points just on the east side, north side of the low, and usually that warm front will extend a little bit to the east of it. So you definitely see some pooling of those dew points. And look at that dry line ejection right into southeastern Nebraska. Really, you want to watch where that dry line nose bulges up into those dew points. Right about there into the Hastings area, you can see that surge of a dry line. Dew points drop into the 20s back behind the dry line, up into the 60s just ahead of it. So you definitely do get a nice dry line bulge lifting right up into south central Nebraska. And storms are likely going to form off of that nose, but then notice how the instability axis gets pinched on the north side. So there is a very narrow window of tornado potential between about 4 and 7 p.m. Any of those supercell storms that can develop off the nose of that dry line bulge and lift north at about 30 knots. The residence time is going to be a little bit short in that narrow instability axis, but any surface-based storms that are able to exist in that environment will certainly have the potential of producing a tornado. And this is a 12Z NAM model rendition of what the storms or the composite reflectivity will look like. Possible snow out here, thunder snow even across southeastern Wyoming into the mountains of northern Colorado. Kind of a sign of things to come for the winter ahead of this El Nino pattern. You'll get a lot of Colorado lows, a lot of upsloping. When those easterlies are forced up the terrain, they'll dump out a lot of snow across the foothills, across the Front Range. And so watch the time right here. You want to watch at about 21Z, which is 4 p.m. on Thursday, 4 hours from this time. Look at those storms that try to develop off the nose of that dry line and then lift off to the north into that stable air. It doesn't look like the most incredible tornado outbreak that'll happen, at least based on the convective mode from the HRRR model, but those early supercells that are able to develop within that instability axis and then lift off to the north at about 30 knots, those are the ones that I'm going to be most concerned about out near Ord, up toward O'Neill as well. And it all depends on the exact track of that surface low as well. Hello, everybody. Thanks for dominating that like button. Definitely not getting as many people interested in the fall severe weather season, as there is a lot going on worldwide, of course, so these lives don't always blow up. I meant to have this to be for Team Dominator members, but this is what I do for the Team Dominator members. We do a lot of these in-depth briefings. We look at all the different models, and we're going to go back to this skinny instability axis by the HRRR model being forecast for 21Z, which is actually 4 p.m. Central Time, Central Daylight Time. And this is that east to west arc of supercells that I'm most concerned about. They form right in that axis of instability. It looks like they form at about 3 p.m., probably even a little bit earlier. Wouldn't be surprised if these get going by about 2 p.m. And back here, you have your more traditional cold core setup. That's along an occluded boundary. You can look at temperature and notice how the temperatures decrease a little bit behind this occluded boundary. So what'll happen is these storms will form in the well-mixed air. They'll cross over this boundary, move into this air mass of low 50s with some decent directional change in the winds too along that boundary. And basically storms will go and they stretch the existing spin on this occluded boundary behind the surface low. So notice how you have these east-northeasterly surface winds. To the south of it, you have more of a southwesterly surface wind. That creates surface vorticity in any of these storms that are able to develop in the well mix there and then cross over that boundary. You can stretch that spin into the vertical, and that's when you start to get tornadoes or cold core tornadoes. Anything to the east of the surface, though, and down the arc, I classify as a traditional tornado setup, and you need those dew points around 60 or into the low 60s, and then back behind it, I consider this pure cold core when they're basically on the occluded boundary, western Nebraska up into Cherry County, southwesterly winds to the south of it, down in this well mix there, which is going to be in the middle 60s. So I'd be on the lookout for cold core tornadoes along that occluded boundary. And then anywhere from the nose and off to the east, you could get some more traditional tornado potential. And we look at the forecast photographs out there. And this is exactly what I mean when you get a lot of those low-level easterlies in the photograph. And you need that for the due northerly storm motion. Anything that's plotted over here is an easterly wind, or at least has an easterly component. Your surface wind is east-southeast to west-northwest. Your wind just above that, south-southeast. You get a lot of directional change as well. And definitely to have a storm motion that's almost due north, a little bit east of due north, you really need those strong easterly winds in the lowest couple of kilometers. You do have a strong elevated mix layer that happens with these potent trough ejections too. It brings that dry air in the mid-levels over top that moisture. And it looks like the HRRR shows nice moisture depth on the northeastern quadrant of that surface low. See how the green line is right next to the red line there? That's actually pretty decent moisture depth, and that's because of the pooling up along the cold front. Up along the warm front, excuse me. You can see the surface low right here and a little bulging up of the warm frontal zone. Basically what happens is a low-level jet will pool that moisture along the warm frontal zone. You get a dry line punch into southern Nebraska that really tightens up by about 21 Z. You've got 30 dew points banking up against that warm front surface low back to the west of it. And then you also get the eruption of all those individual storms. So there's your 989 surface low, still intensifying at this time, going up into 4 p.m. And just to the east of that, you can see those easterly winds along a narrow warm frontal zone. And that warm frontal zone is very narrow. We look at it sounding right off the bulge of the dry line, and wow, look at that photograph. You've got a surface wind almost due east. You've got a 1 kilometer wind south-southeast at about 35 knots. And your 2 kilometer wind is banking up against 40 knots and plenty of strong upper level winds to encourage those meridional storm motions. But it's all about the easterlies at the low levels here. So look at those easterly winds up through 1 kilometer. And you also have a decent moisture depth too. Look at how deep your moisture is, where the green line is relatively close to the red line. And then you get your dry, elevated mix layer coming in over top that moisture. Those are the basics of instability. They act to steepen those lapse rates. You've got a lot of strong southwesterlies in the middle and upper atmosphere, and an even more favorable photograph with a very long storm relative inflow vector. The length of that vector right there from the tip of the storm motion vector, which is south-southwest to north-northeast, all the way back to your surface wind at the photograph curve, the length of that vector is proportional to storm relative inflow. The longer that vector, the greater the inflow into the storm. And what this tells me is that at least in that narrow corridor of instability in central Nebraska, there's likely going to be a pretty favorable setup for tornadoes. And look at that, some supercells developing just to the east of the low. You're going to have more traditional cold core back behind the surface low. See what we got for significant tornado parameter. Even your significant tornado parameter looks pretty decent in that arc. And it still is there at 5 p.m. at 22Z, just meandering off to the north just a little bit. But it is a pretty narrow zone. So once these storms move through that narrow instability axis and move into that stable air, they're going to become elevated and have a little bit less likely of a tornado potential. And already by 6 p.m., we start to lose some of those brighter colors near the warm frontal zone. As you get a couple of rounds of supercell storms that develop through that instability axis, they stabilize the atmosphere and you lose a little bit of the instability. It gets pinched off into southeastern Nebraska. And then you start to get a little bit of a capping inversion as you move south into that deeper instability. And if we look really close here at the low levels of the atmosphere, and especially up a little bit higher, watch as I move south on the instability axis, you'll see a little bit of a capping inversion develop. You get a little bit less in the way of easterlies in the lowest levels of the atmosphere as you get a little bit separated from the warm frontal zone, but still a very favorable shaped hodograph with strong 0 to 1 and 0 to 3 shear. And your helicity is proportional to the area enclosed by the hodograph curve and your storm motion vector. So basically this area right in here, depending on what level you're looking at, that's proportional to the wind shear. And you definitely want your critical angle to be as close to 90 degrees as possible. A 90-degree angle, that means that you're pulling in pure streamwise vorticity at the low levels of the atmosphere. And then as we go toward 0Z, your instability axis even gets more pinched off. But then your low-level jet starts to increase out of the south. But I think that down here, despite that low-level jet increase, the instability axis is so narrow that with a more west to east storm motion, it's going to be sliding right through that axis. So I am seeing a very narrow window of tornado potential. Central, eastern Nebraska, and there's your 0 to 3 kilometer EHI. Looks pretty favorable across that zone. Let's see what our updraft helicity tracks look like. And we do get a couple of these northerly movers right in central Nebraska. That looks like a pretty long track supercell forming right off the dry line bulge and lifting due north through central Nebraska. That'll definitely have some potential to produce some tornadoes, especially where it's able to interact with that warm frontal zone. You can also see some cold core tracks as those supercell storms fire really tight to the surface low and try to wrap around the surface low. Anywhere across this zone certainly does have tornado potential. Central Nebraska, further east as well. Notice how this helicity track has a little bit more southwest to a northeast orientation. Has more west-east orientation. That's because of how compact the jet structure is. And you can actually see a little bit more westerly flow on the southeastern quadrant of this egg-shaped upper-level vortex. The reason why we call it a bowling ball of cold air, when you look aloft, you've got very cold air, minus 16, minus 15 degrees C. And then the jet, of course, coincides where you have the strongest temperature gradient. And that basically happens from central Kansas up into southeastern Nebraska. Very strong temperature gradient below it as well, if you look at the temperatures below. Basically through the thermal wind relationship, the jet stream up in the mid and upper levels of the atmosphere is driven by the temperature gradients below it. And there's your jet. And you really want to target the ski jump of these upper level jets. So you can see the terminus of that jet streak as it's nosing up into central and eastern Nebraska. Notice how a lot of these upper level winds are oriented due south to north, 50, 60 knots due south to north there. That's what's triggering the meridional storm motions and the need for these easterly winds. This is another negative that's being depicted by the NAM model, is the 850 winds or the low-level jet are a lot more due southerly until you get up to the warm frontal zone, and you're going to need these east-southeasterly 850 winds, as we just proved with the hodograph. There is the regular resolution NAM, and you go over to the HRRR, and it seems to have a better handle of how compact that upper-level storm system is, at least at the low levels, and how vertically stacked it is. So the 500 millibar vort max, you go down to 850, they're all co-located down to the surface low. That's what we mean by a vertically stacked low. And then you get that front back behind it. This is an occluded boundary. To the south of that, you have more west to east oriented winds. To the north of it, you have more northeasterly. And right where those coincide, you get a lot of surface spin or surface vorticity that develops. You look at 0 to 3 Cape to see where you get that greatest sunshine, co-located with the surface moisture. Basically, anywhere east of the surface low, you get a ton of 0 to 3 kilometer Cape, and that's going to lead to those steep lapse rates in the very low levels of the atmosphere that you need to generate tornadoes. So I do think this is a big-time event out here, central eastern Nebraska. And notice how the instability doesn't really build down into eastern Kansas much. You're going to have a lot of cloud cover down there, a skinny instability axis. But right where you have that strongest 0 to 3 kilometer Cape, you get a lot of surface heating, and it's right near that warm frontal zone. A lot of that is driven by that elevated mix layer, mid-level dry slot just above the ground. And you do get a little subtle capping inversion. The further away from the surface low that you get that little warming, that little warm layer, which is an inversion right about there, just at the top of the moisture. But you still have very favorable photographs, good critical angles as well. So I do think that this is going to be a pretty significant tornado event. We head on over to Twitter to look at the NATOcast, and obviously the machine learning products are picking up on the potential for tornadoes tomorrow across eastern and central Nebraska. Late night tonight, it looks like that tropical low that's moving up through the northern Gulf of Mexico could eventually bring tornado potential near the Tampa area, north of Tampa. Gainesville could also get in on the tornado action late night tonight and extending through the day tomorrow. And it's really this moisture grabber in the northern Gulf of Mexico that's preventing more robust moisture from lifting northward through the Great Plains into the warm sector of this system. If we didn't have this Gulf of Mexico system, then I think that we'd probably be dealing with a tornado outbreak across central and eastern Nebraska, Kansas, portions of Oklahoma too. Could be in that zone. And then let's take a look now at the threat the following day as well. We're going to have to use the 3-kilometer NAM, of course, which there still is some disagreement, especially at the low levels, between the 0 to 3-kilometer NAM and the HRRR model, which are kind of our go-to models. It does look like that around 21Z, there could be a little slice of action here into southeastern Iowa, as you can see. So it looks like on Friday, the threat of those low top supercells will push off to the east as the low advances into Iowa. And so just get a little bit less instability, though. A lot of times these cold core events are one day and then done instead of just 2 days stacked back to back against each other. I do also want to show you the Rufus model, as everybody's calling it, which is pretty aggressive when it comes to generating precip and storms as well, but we'll go at least to 21Z. Looks like it does pretty well with surface-based instability up over 1,000 CAPE and a lot of CAPE right underneath that low, that vertically stacked low. That's because of the minus 16 degrees Celsius air in the mid-levels of the atmosphere. But watch what this model does in terms of supercells. At 21Z, has some supercells developing just over the northeastern quadrant of the surface low. There's your surface low, 985. Analyze a little bit further northwest, and maybe it could be. And it looks like just on the east side of that low is where the Rufus model initiates that first supercell storm. And then as we go to 22Z, just an absolute eruption from central into southeastern Nebraska, down toward Hastings, up toward the Ord area. Could get into some big time severe weather. That's at 5 p.m. And then it's probably going to start lining out and unzipping of that line. Definitely could get some rain wrapped tornadoes right underneath the core of that surface low and beneath the upper low as well. Just on the east side of that low. So it's not a pure cold core setup where these supercells evolve. If you're back further west of the surface low, along that occluded boundary, directly beneath the cold air loft, then I would call that more of a pure cold core event. But in this case, they're a little bit further east. There's your occluded boundary, further west of the surface low. And you get a nice instability axis that lifts north to the south of that warm front. The warm front goes through Omaha by 6 p.m. And temperatures into the mid and upper and mid 70s, low 70s there, 73 in Omaha. That looks pretty good. And look at that unzipping. What an arc you got of supercells, probably with embedded tornado potential, but does seem to grow upscale by about 7 p.m. So you do have a narrow window to get that tornado potential across central and eastern Nebraska. The Rufus model is pretty aggressive with its convective initiation, though. Look at that. Just starts to crank. Heading over to the chat. Let me say hello to everybody. It's a lot easier to manage the chat when I do my member lives, that's for sure. But I probably should just set this to subscriber only, and then I can see them a little bit more. But I like to do these member only briefings because a lot of times when I go in depth like this, I'll start losing viewers. People just don't want to hear it. They don't really like the in-depth approach. But the members certainly do. Team Dominator members seem all about them. And look at the rufous surface temperature, 77 over 59. Usually about a 20-degree spread you need. It isn't at the max you want to have cloud bases low enough to have a robust tornado potential. And this is at about 18 right there. Definitely some decent moisture, even by the rufous, and some even better surface heating, which makes sense because you have such a stout, elevated mix layer coming in at the mid levels that there should be plenty of surface heating for tornado potential. And you can still see a lot of those easterlies in the lowest couple kilometers there. Nice hook-shaped photograph, pretty strong mid and upper level winds too, helping to encourage that meridional storm motion, south-southwest and north-northeast. Looks like a pretty favorable setup to me, folks. But not the classic cold core, I think that everybody says, but I probably am overthinking it as usual as well. But there's the upper level system, ejecting. That's the 6Z NAM. We'll go back to the 12Z. And actually, the NAM gets even more compact than upper level storm system. The more compact that vort max of 500 millibars, I think the more vertically stacked it'll be. And you'll probably get a little bit more moisture pooling as well to the east of it. And it does seem like we're trending toward a more compact 500 millibar low, especially with the HRRR that's really able to resolve how compact that 850 low is and the associated 500 millibar vort. Notice how it's not perfectly vertically stacked. They are a little bit offset. But then you get the occluded boundary back here to the west of it. That's basically a frontal boundary. To the north of it, it's a little bit cooler, more moist with northeasterly surface winds. To the south of it, it's warmer but more dry. And so what'll happen is these storms will develop in the drier, well-mixed air, and then they'll cross over that boundary into the better moisture. And a lot of times they'll stretch that into the vertical, and you can even get tornadoes up here, more classic cold core tornadoes. Botched up photographs, but you'll get a lot of stretching of the existing spin right along that boundary. See if we can pick a sounding right along it. Decent cape as well in that layer. Definitely a lot of pooled moisture in central Nebraska. Dryline bulge that we've been analyzing, especially with the wind barbs. You can see it. Look at those southeasterlies. Southeasterlies slamming into those east-south or southwesterlies slamming into the east-southeasterly surface winds. All right, here is your belt of easterly surface winds. The barbs point into the direction that the winds are coming from. And then you can see these southwesterly winds nosing in. That's your dryline bulge right about here. Nosing up into that big belt of west to east oriented moisture. Near 60 into the low 60s dew points. Nice pooling. There's your warm frontal zone extending a little bit east. But you definitely do carve out those dew points a little bit. And that's because of the system down in the Gulf of Mexico. That is going to be grabbing that moisture a little bit. That's obviously a weakness of this system. I'm going to be monitoring the models this evening, and I might have to fly into Omaha, rent a car, and then blast west. But honestly, this season, I've probably been just chasing everything since like January, and that's what's led to the destruction of my immune system. So I think the smart thing to do is just to recover and rest and watch this thing, watch the dryline bulge evolve. Watch these northerly moving supercells moving at 30 through that axis. Another weakness is that instability axis is quite skinny. And when your storms are moving at 30 to 40 knots, the residence time within that is probably just enough to develop tornado potential within that zone. And you definitely lose the thickness of that moisture a little bit further south. If we have deep moisture, you'd be talking about tornado potential all the way down through eastern Kansas, maybe even into Oklahoma with like 70 dew points. But given the moisture limitations, it looks like your tornado threat is going to be focused across central and eastern Nebraska, and that's about it. So those are my 2 cents, everybody. I do think that there's decent tornado potential with these northerly movers across central Nebraska. Easterly surface winds, easterly low-level jet, kind of a skinny, meager moisture situation further down. I'll show you how the capping inversion gets a little bit more robust as we go into northeastern Kansas. There's your cap. That little warm layer that you see down here to the south of that convective arc, that's going to try to limit the development of convection further down the dry line into eastern Kansas and other portions of southeastern Nebraska. despite a lot of heating out there and a decent hodograph. Whenever you get that big capping inversion and a little bit of subsidence, I notice that you always get this little kick in the hodograph here. Kind of a contribution of negative storm relative helicity within the hodograph. That's one thing that I've analyzed. And you also get a reduction of that low level shear. You get a lot of mixing out there further down the dry line. You lose some of those good dew points. Your dew points are in the middle to upper 60s, and that leads to a more unfavorable wind shear profile as well. And I do think that despite those weaknesses, a lot of times these October setups will happen just to the east of those big surface lows. Reminder is like in 2004, I think it was right around the same time, October 11, central and eastern Iowa, there were crazy tornadoes that developed just to the east of the surface low up there, and I definitely wish I chased it. By about 22Z, the surface low has peaked and starts to weaken. And then it starts to fill in a little bit, lift up into the low 990s. And look at that, 993 in eastern Nebraska. It's a little bit less favorable. So the timing is only going to be there for a couple of hours, central and eastern Nebraska. Thanks, everybody, for tuning in. Yeah, I did do some leaf peeping yesterday, but here over the southeastern U.S., the problem with that coastal system is that it overspreads a baroclinic leaf. You get a lot of high clouds that will advance out ahead of it, and you start to lose some of the sunny skies that will illuminate a lot of those trees. I know that you can go for a lot of those moody situations out there. Mario, I am considering chasing tomorrow. I would like to chase tomorrow. Looks pretty good. There's Storm Runner Media in the house. Wedding to go to this weekend. Oh no! Hopefully it's their first wedding. If it's their second or third wedding, you don't have to go. You never have to go to somebody's second or third wedding. I think the Florida tornado threat looks pretty good, Frozen Relic. I'll take a deeper look at it for you right now. It's going to be late night tonight. We can look at the HRRR model. I know there's a lot of people on here from the Tampa area as well. And there it is. There's your coastal low, right off the southeast of Venice, Louisiana. And you can see it here on the surface map. And this is going to have to migrate off to the east. I don't think that you're going to get favorable conditions for tornadoes across central and northern Florida until late night tonight, probably like 9, 10, 11 p.m. But that's your surface low. And the reason why these are moisture grabbers is because you get northerly winds on the backside of them, and that'll carve out the moisture. And then when that system finally ejects across the plains and excites a low-level jet, you get very shallow moisture that lifts northward to the east of that surface low. But let's see when the timing is going to be for that severe weather. We're looking at the low-level jet here. Really maximizes just to the east of the surface low. You're looking at about 8 p.m. Eastern Daylight Time. You start to get the invasion of that decent low-level wind shear into the Tampa Bay area by about 4Z. So there it is. There's your little coastal front that's going to come on shore, and it looks like it happens at about 10 p.m. Lifts right to the Tampa Bay area, and then it's going to be followed by your belt of convection. But pretty good hodographs at 10 p.m. near Tampa. Northeast storm motion at about 20 knots, 79 over 78. A lot better moisture than we had out in the plains. Pretty deep moisture, nice low-level jet spiking up near 40 knots, and it's only going to get more robust, 40 to 50 knots as you go through the day. A lot of deep moisture, though. Look at that. Now, that's deep tropical moisture when it goes all the way up to the triple pause. A little bit different than what we're getting in the Great Plains. Tall, skinny cape out there. Notice how we have no elevated mix layer. That's because this is a subtropical system, subtropical origin. Get a lot of that tall, skinny cape that happens. But then at about 10 p.m. into midnight, the conditions really improve for tornado potential down in the Tampa Bay area. And you also get convection moving in. HP bombers coming in to west central Florida, including Tampa Bay, up toward the Nature Coast. This one a little bit closer to the surface low is probably going to remain offshore of Apalachicola, but probably going to get some water spouts over the open ocean. But yeah, these are going to be supercells moving into an environment capable of tornadoes and maybe even a significant tornado or two. down across the eastern Gulf, nosing up into the Tampa Bay area. Got to get the sound effects on here so everybody stays watching. And as we go toward midnight, the environment gets even more favorable near Tampa Bay. Plenty of surface-based instability. And look at how that photograph elongates. Deep moisture, 80 over 78, 0 to 1 kilometer storm relative felicity of about 270. So I can read these numbers down here for storm relative felicity. And if you have greater than 200, 0 to 1 SRH, you're dealing with some pretty good wind shear, supportive of even tornadoes. And you definitely want to look at more of the 0 to 3 kilometer shear when you're back in the high plains of like eastern Colorado into the Nebraska Panhandle. But notably, as I go toward midnight, notice how that low-level jet increases to like 50 knots up there. And that expands the low-level wind shear. You got a southwest to northeast storm motion on that photograph, and then the wind field spiraling around it. So you have storm relative inflow all the way up to about 3 kilometers. Usually you have a more favorable storm when it has a lot of inflow in a storm relative sense at the low levels, and even a bit of ventilation aloft. And when you have those strong mid and upper level winds, they're pulling that rain out of the updraft a lot more effectively, and also encouraging a storm motion that's favorably oriented for the wind shear. You need a storm motion that's far enough right so that you can still get pure streamwise vorticity intake. You want it to make a 90-degree angle with that low-level wind shear vector. And to me, this looks like a sounding that's supportive of HB supercells that will be likely producing tornadoes. And it looks like it's centered right near the Tampa Bay area, 10 p.m. through midnight, even 1 a.m. into the early morning hours. And you might even get some instability coming ashore near the Florida Big Bend. I think that Friday, Johnny Half, is going to be more of a southeastern Iowa type change. Yeah, I had a fruit fly that was bothering me when I was trying to go to the bathroom this morning. Just sitting there, and this little fruit fly's flying all around. Never stop chasing. Team Jesus, John Boy McGuire. Let's go. Hey there, Michelle. Dartha Washer. Nice. Oh, yeah, I do talk with my hands a lot, a little bit too much. My mom does that too. That's probably where I get it. It does look like there is a pretty small zone for tornado potential across central and eastern Nebraska tomorrow. That's definitely a limiting factor that could happen. Yeah, I might need to buy a plane ticket as well. If I do, it would be early morning tomorrow. I'd roll into Omaha. I'd rent a car, head west, probably blow the windows out if I get into some big hail. And I'd be right on those supercell storms, moving from south to north, crossing through that destabilized warm frontal zone. Andrew Justin getting out there dominating. Good chaser. How's it going, Don? Candlesticks, eh? Yeah, similar to the stock market. I mean, most mathematics are relatively similar, especially between economics and meteorology. That's for sure. At least the stats portions. But I do want to look at the long range too, as I've got everybody here. But yeah, I might have to sit this one out just because I've had a freaking cold for like 3 weeks. It'll start to get better, and I feel like it's totally gone, and then I start to grind again, and then it keeps coming back, which is kind of scary. But boy, look at that bulbous trough ejection. And different than the last one, this one does have a lot more flow on the back side of it, at least when it's ejecting from the Mountain West and across the Great Plains. The shore hugger does get out of there pretty quickly by Thursday afternoon. It's across northern Florida, so I do think that the more progressive southern branch is definitely a positive for this thing producing tornadoes tomorrow. Boy, look at the GFS. Has another contour. That's the 12Z GFS too, a more potent upper level system. And remember, you always want to target the ski jump, the jet exit region of this, which is nosing into eastern Nebraska here. Let's see what the long range looks like. Looks like a cold eastern U.S. reinvigorated again. Ooh, we got a little close low dropping south next week, Thursday. Little bird fart of an upper level system, though. And boy, it looks like this could be kind of the last severe weather for a little bit before we transition to more of a zonal flow or even a ridge trough pattern. Usually, when you get the ridge across the western U.S. and a trough across the eastern U.S., it's a lot less favorable for severe weather. Boy, this is a very textbook trough. If this didn't have this southern stream system, this would be a major tornado outbreak. There's your cold air aloft. I do like how that blob of colder air kind of extends to the east of the main fort. That could destabilize things a little bit more quickly right near the surface low. I do think that there is a little bit more tilt than we think too. Look at that vort over northeastern Colorado with the secondary surface low back there. New surface low, almost like a cycling tornado happening here. So a very dynamic system. And I do want to look at some of the snow too that falls in the northwest of this thing. Look at that vort, double-barreled vort max. It's like a cycling tornado where you get this right underneath that potent vort. Look at that. And then your new surface low forms a little bit further off to the east. Just like cycling tornadoes. Wow. That's crazy. We got a 985 low out here. I think that this would be a little bit less conducive for severe weather if you have this cycling situation, or instead of kind of a more robust dominant surface low. But yeah, if it happens like this, it would definitely reduce the tornado potential a little bit. And it does look like we start to get some snow across southeastern Wyoming by Thursday late afternoon into evening. Possibly some heavier snow sliding into the Nebraska panhandle by Thursday evening. I saw some of those projections are showing greater than a foot of snow in the Nebraska panhandle. Probably not going to happen. But over the mountains of southeastern Wyoming, easily could happen. In the mountains of northern Colorado, southeastern Wyoming, all the way down to the I-70 corridor. Definitely a sign of things to come for the ski season out here, Mountain West, western, northern Colorado, Wyoming. I think we're going to get a big snow season out here from the Sierra Nevadas through the mountains of Utah, Colorado, especially the first half of the winter. I think the second half of the winter, you're going to have an active southern branch of the jet, more air mass protrusions, more of a ridge trough pattern, and the potential for more of those nor'easters to lift up the East Coast. But you got to have a favorable Atlantic climate system as well. So it looks like the Nebraska Panhandle totals have gone down a little bit, probably talking about a wet snow in the grassy areas, 2 to 3 inches Thursday night on the backside of that storm system. Let's look at the SPC really quick, and then we're going to shut this down. SPC, that marginal risk is for nighttime convection that could develop over central Nebraska. But we do have our 5% risk that actually includes Apalachicola, the Nature Coast, all the way down to Tampa. Same areas where we intercepted Hurricane Idalia. Idalia! Idalia! Ooh, we got a 1730 outlook. 5% has been added across central Nebraska. We figured that was going to happen. There it is, everybody. 5% zone. Central Nebraska, southwest of Norfolk, the Ord area, right in that zone of central Nebraska. Definitely agree with the boost in that 5% zone. It used to be 2% until this morning. Yeah, just basically stating the basics. Narrow corridor of upper 50s to low 60s will be present, at least along the warm frontal zone. Cooling aloft, steepening lapse rates, capping with southward extent into Oklahoma will decrease the diurnal thunderstorm potential. Mentioned may then increase on the dry line into the evening. Nebraska is the interesting part. The warm front will extend eastward from the low. Now, guidance varies. Some camps suggest a conditional risk of elevated convection is possible overnight into the portions of north central Oklahoma. Low-level shear will become enhanced near the triple point. Locally backed winds expected. This would be a more favorable location for a couple of tornadoes. So, yep. Let's look at the wrap model, though, really quick. I probably wouldn't put out a 10% yet until we get an idea a little bit better of the trough ejection. There are definitely some discrepancies between the models on how strong the surface low will be, how vertically stacked will it be too. There's the wrap going out a little further. Yeah, so the wrap model a lot of times does a pretty good job with these setups. And it looked really favorable yesterday, but let's see what it looks like on this setup. Surface low. Ooh, at 992 low. Not as strong as some of the other models. Oh, it just fills in a little bit faster by 0Z. Still hasn't reaching the upper 980s, but notice how these higher resolution models don't just spin up the real intense surface low directly underneath the cold core. You got these easterlies just to the east of the triple point. Anywhere north, along and north of that warm frontal zone will be where you want to target. And there's your target area. Pretty well defined. South central Nebraska. The HRRR is a little bit further north of this, having it further up into central Nebraska, a little bit more of a wraparound situation. But yeah, right there near the triple point. All the models are showing an environment that's quite favorable for tornadoes. Residence time in that narrow instability axis is going to be a little bit smaller, but I do think that definitely has some potential of being a very chaseable setup. So thank you, Team Dominator. Thank you, Team Dominator members, for tuning in. I usually do these in-depth briefings, more so for Team Dominator members. I've actually been on the road nonstop, man. Yeah, it is Andrew Justin. There he is, one of the bright minds. But yeah, it has all that convection, leading to some latent heat and some more surface pressure drops. Just runaway convection forming. Yeah, I'll chase with Chad again. Chad is a good chaser. Really enjoyed teaming up with Chad for the Rolling Fork event, especially with kind of his first responder training. Definitely helped out a lot. The RRFS does have a lot of convection compared to the other models, but notice how the entire time this year, the real setups will convect a lot more than many of the models are showing. So the RRFS might even be onto something too. I think you'll probably have earlier firing of storms. You'll probably have greater coverage of storms as well. Thanks, American Patriot. Thanks, Kelly. I'm feeling fine. It's just my nose and like the cough there that's just been persistent. Just can't seem to shake it. Yeah, really just got to go out there and chase. You're not going to see anything if you don't get out the door. But I also don't want to infect everybody if I do go chasing. There's your narrow zone. See how the surface lows compare. 990 at 21Z. It's definitely going to be shifty, really shifty along this little wiggle. There's the occluded boundary back behind it. Maybe some pure cold core convection with that. But I always think anything on the nose of the instability axis near and to the east of the surface low is just low topped, high shear type of a setup. Here's your 3-kilometer NAM. Wow! 3-kilometer NAM goes nuts with that surface low, even more so than the Rufus. 3-kilometer NAM. The NAM model has looked weird this entire setup, though. Just hasn't been able to resolve it. Yeah, I would say that the 3 kilometer Nam and the Rufus are drinking the same Kool-Aid there. I think that low probably will be near 990. Definitely not 981. Yeah, that's all latent heat release, isn't it? What happens when you get rapid condensation, like with a cluster of storms like this, for example, you get a lot of condensation. It releases the stored energy, heat energy, in the water molecule, and that leads to pressure falls in the lower atmosphere. And so I think that's leading to an erroneous intensification of that surface low in the central Nebraska. HRRR is probably more accurate, kind of turning into this more broad surface low. But all of the tornado threat depends on how compact that surface low is. We can go back to the GFS that's doing some crazy things with this double barreled low. It's a model error, I would say, leading to kind of a weird distribution of the 850 winds, surface winds. Then we got to use the higher resolution models to pick out these small scale features. So thanks everybody for tuning into this emergency weather briefing. If I can dramatically improve, I'll fly into Omaha again for another setup. But definitely trying to never stop chasing all the way till the end. Now we got to gear up for winter weather too. And I'm working on a book as well. Maybe we'll call it Dominate the Storm instead of Into the Storm. I was looking at the 60 HRRR, by the way. Definitely had a good trend from 60 to the 12Z run with that skinny little instability axis. Thanks everybody for tuning in. Yeah, the Bighorns of Wyoming. That's going to be the place to go if you want to get some good snow. 10 to 20 inches, 50 plus mile per hour winds tonight through Thursday even. I have many favorite tornado chases. Raptor, my favorite probably this year was Yuma, or probably Cole, Oklahoma was one of my favorites. That one that was turning off to the due left. But Super Outbreak was a crazy chase. April 27, 2011. Manchester, South Dakota, 2003. Pipestone, Manitoba, June 23rd, 2007. Bottle, of course, is a big one. I really like those chases where I dig a tornado out of the rain too, because it takes a lot of skill to do that, a lot of navigating the storm and understanding storm structure. So I do enjoy digging a lot of those tornadoes out of the rain. Thanks everybody for tuning in, and remember those 3 most important words: never stop chasing.